The first method is for getting the gradient function of the circle, which is dy dx. Method 2 is the concept of perpendicular lines. So I'm going to start with method 1. We are using part B. We are solving part B. Part B, we are given 2x squared plus 2y squared plus 9x minus 4y plus 4 equals to 0. The question says that find the equation of the tangent to this circle at the point of tangency -2 and 3. -2 and 3. This is what we call the point of tangency. That is a point on the circle where the tangent meets the circle or touches the circle. So for us to apply method 1, that is the method of getting the gradient function. Number 1, it is not necessary for us to sketch the circle as long as we know the point of tangency. Number 2, it is not important for us to ensure that the coefficients of x squared and y squared are 1. We can use it the way it is. We can use the equation of the circle without necessarily making the coefficients of x squared and y squared 1. Why? Because we are not going to find the center and we are not going to find the radius. So let us differentiate both sides. So I will have dx of the left hand side of the equation, that is 2x squared plus 2y squared plus 9x minus 4y plus 4, close the bracket, because ddx applies to each of these terms, equals to dx of the right hand side, which has 0. Now we need to consider this equation of the circle as an implicit function. So we're going to differentiate it as an implicit function. So if we differentiate 2x squared, what do we get? We get 4x. This is a function in x, so we attach the x. But we are differentiating with respect to x. So dx plus, if we differentiate 2y squared, we get 4y. This is a function in y, so dy, but with respect to x, dy dx. Plus, if we differentiate 9x, we get 9. This is a function in x, so it is dx with respect to x. And then here we have minus 4y, so we put here minus. If we differentiate 4y, what do we get? We get 4. This is a function in y, so we say dy, but with respect to x, so dy dx. If you differentiate a constant 4, it gives us 0. So plus 0 equals to, if we differentiate a constant 0, we also get 0. Now from here, we need to simplify. Dx and dx cancel here, dx and dx cancel here. So that therefore we have 4x plus 4y dy dx plus 9 minus 4 dy dx equals to 0. Now from here, remember we are looking for dy dx. So we need to find a way of making dy dx the subject so that it defines for us the gradient function. So I'm going to collect like terms dy dx together. Thus I will have 4y dy dx minus 4 dy dx, this and that. Now I'm going to carry 4x and 9 to the other side of the equation. So they will change to negative 4x minus 9. The order doesn't matter. Even if we say negative 9 minus 4x, it is the same. Now we need to make dy dx the subject. So let me factorize so that I have 4y minus 4 dy dx. This gives us a negative 4x minus 9. Therefore, making dy dx the subject, I will say both sides by 4y minus 4. So it gives us a negative 4x minus 9 out of 4y minus 4. This is the gradient function of the circle. This is the gradient function of the circle. What is the purpose, or why is it important for us to have the gradient function? It is to define for us what the gradient of the circle would be at any point on the circumference. So, the point of tangency, remember, is on the circumference. So, if we have the gradient function and we have the point of tangency, which is any point on the circumference, then we can find the gradient of the circle at the point of tangency. So therefore, say at the point of tangency, which is negative 2 and 3, we can find the gradient of the circle using the gradient function. So here we shall have, therefore, dy dx at the point of tangency negative 2 and 3. This one now is going to give us the gradient of the circle. So this is x, this is y. We substitute for them here so that we have negative 4 x is negative 2 minus 9 out of 4 times y 3 minus 4. We have substituted for x and y. Now let us get that gradient. Let's simplify this expression. So negative 4 times negative 2 minus 9. I'm getting here negative 1 over 4 times 3 minus 4. I'm getting 8. So this is the gradient of the circle. Okay, that is the gradient of the circle at the point of tangency. What do we know at the point of tangency? We are saying that at the point of tangency, the gradient of the circle is the same as the gradient of the tangent. Therefore, gradient of the tangent is going to be the same as the gradient of the circle at that same point of tangency. Now that we have the gradient of the tangent and we have one point on the tangent, that is the point of tangency, we can therefore find the equation of the tangent. So equation of the tangent. Now the equation of the tangent here becomes we have one point already on the tangent, that is negative 2 and 3, and then we have the gradient n of the tangent, negative 1 out of 8. The tangent is a line, therefore the equation becomes y equals mx plus c. This is x, this is y. Substitute 3 equals to, what is m? M is negative 1 out of 8 times x. X is negative 2 plus c, where c is the y-intercept. The point on the y-axis where the tangent cuts the y-axis. So negative 1 divided by 8, negative 1 divided by 8 times negative 2. So here it becomes positive. So if I take it that side, it becomes negative. So 3 minus answer. So I'm getting my C. Therefore C is 11 out of 4. Let me press that again. Negative 2 times negative 1 divided by 8. 3 minus answer. Yes, this is C. Therefore, in writing the equation of line, you substitute for M and only C. Therefore, y equals to, what is M? Negative 1 out of 8 x plus c, which is 11 out of 4.